So today we are going to revisit decision tree. So before revisiting decision tree, we have to understand that what is information and how we can quantify it. So let us take an example. So let us say that there are two sentences, right? That there is a traffic jam on 15, that is 22 letters, and there is a traffic jam on 15 near exit 234, that is 33 letters. So you see that the second information contains more number of symbols, and therefore it contains more information than the first sentence, right? So information is quantifiable, that you understand from this example. So basically, how to quantify? Let us so it was first attempt was made by Hartley in 1928. So let us say if there is a message and it contains only a single symbol, so it single symbol, and it might have some S possibilities. Right? How many possible symbols it can have, right? And if the message length is L, so there are total S to the power L distinguishable possibilities. So the information measure is measured in, therefore I equal to log S of S to the power L equals L log of S, right? That is how we try to quantify information. So basically one letter has this information of log S, right? So if there is only message 1 and it has only one symbol, then it has information of log of S. But if it is a message of length L, then it contains L times more information. So it becomes L log S. So basically the information can be quantified, right? Now let us a more generalized concept was given by Shannon. So what is the Shannon's entropy measure? So Shannon's measure of information is the number of bits to represent the amount of uncertainty in a data source, and is defined as entropy. So he gave it simply that the is H equal to minus summation of I equal to 1 to n Pi log Pi, where there are n symbols 1 to n, and each of this probability of occurrence is P to the power I. So there are n informations, n symbols available, and each have a probability of occurrence that is Pi, and the total Shannon's entropy calculated, that is, let us understand, that is H minus Pi log Pi. So entropy becomes reaches at the highest point when it is basically it cannot be both, right? It can be both yes and no, that is 0.5 log 0.5, right? And it becomes 0 if the probability of occurrence is 0, or it becomes fully 100%, that is 1 log 1, it also becomes 0. So let us see then what is decision tree. So decision tree is a classification and prediction tool having a tree-like structure where each internal node denotes a test on an attribute, and each branch represents an outcome of the test, and each leaf node holds a class level. So basically in a decision tree, when you go from the root towards the leaf, you reach a decision, right? So in each internal node represents a test on a particular attribute, and each branch represents the outcome, right, of the test, and each leaf node holds the class level. So how to compute information gain? When the number is either yes or no is 0, or yes or 0, the information is 0. So basically the information of a message is, we can say, is 0 if it is certain, right? When it is either yes or no, then the information is 0. But when the probability of the yes or no is equal, right, the information reaches the maximum because we are uncertain about the outcome. Now what is the complex scenario? The measure should be applicable to multi-class situation where a multi-stage decision must be. Okay. So let us do the mathematical part of information gain is what? Information gain can be defined as the amount of information gained about a random variable or signal from observing another random variable. So if there is a parent variable and it looks at the weighted average entropy of the child nodes, and if we subtract them, the parent variables, the weighted average or entropy of the child nodes from the parent node, so we reach the we reach what you can say the information gained on a random variable. So if let us look at an example. If there are, so let us say there are 4 features: outlook, temperature, humidity, windy, and there is a class called play. Right. So we have to compute the information gain on each of the features, that is outlook, temperature, humidity, and windy. Right. So what is the stepwise way to find the decision tree? So the first is we have to find the entropy of the class variable. So you see there are around 5 no's and 9 yes, right? So it is, so the entropy of the class variable is minus, so it is the parent now, minus 9 by 14 log 9 by 14. That is minus is, and within bracket again, 5 by 14 into log 5 by 14, it is around 0.94, right? So now we have to find the entropy of the child nodes. For outlook, it is, let us say, for outlook sunny, it is 3s node. So these are the things. So weighted average means, so 5 by 9 into minus 3 log, minus 3 by 5 log 3 by 5, minus 2 by 5 log 2 by 5. So you see like that way, you can compute it. So minus 14 into E3 to E2, 4 by 14 into E40, 5 by 14 into 3. So you see 5 by 14 minus 3 by 5 log 3 by 5 minus 2 by 5 into log 2 by 5. Same thing happens with all the outcomes. 4 by 14 into log 40, 5 by 14 into log 2 by 5 log 2 by 5 minus 2 by 5 log 3 by 5. So it comes around 0.693. Now this is computed for each and every attributes. So for outlooks, we compute the information gain as 0.94 minus 0.96, 0.247. For temperature, it is 0.029. For humidity, it is 0.152. For wind, it is 0.048. So we select the higher feature with the highest gain. In this, it is this one. That is outlook. 0.247 is greater than 0.029, 0.152, and 0.048. So we select the feature with maximum information gain. So outlook it is. So outlook is divided into 3 parts: sunny, overcast, and rain. So in this we see that the you can say for overcast it is all yes. So and for sunny we have to look into other features also: temperature, humidity, wind. And for again for rain also we have to look into the other features, that is temperature, humidity, and wind. So let us look. So now we have we know that the first node of the decision tree is created, which is outlook, the first decision attribute. So it is sunny, overcast, and yes. For overcast it is all yes. For sunny and rain we have to find out. Now for sunny we have to find out. Let us look at sunny. Now it is sunny. Now the children are again, you can say that temperature, humidity, and wind are basically the new attributes. And we have played football, we have find it. So we have to again find we have to repeat this thing. So we have to find the class variable again for sunny. So it is again, you can say 0.971. Now for temperature, humidity, and wind, we have to find the information gain. So for temperature, it is around 0.4. So like this way, we find the information gain. For temperature, it is 0.571. For humidity, it is 0.971. For windy, it is 0.020. Likewise, now we select what we can say for, so in this way, the highest information gain is humidity, 0.971. So we see for humidity, let us see, for humidity, it is all no, and for normal it is basically yes. So basically, so for humidity, we select is high and normal, no and yes. Similarly, we find out for the windy, and finally we get the final decision tree. So I hope you understand. So there is an assignment. I'll give it to you in this class only.